Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to look at power properties for exponents. So let's go ahead and get started. Our first one is going to be the power property for exponents. And so how this property looks is as follows. When I have a to the m to the n, it's the same as going a to the m times n. Now, right now this looks kind of mysterious, so why don't I go ahead and give you an example. Let's say I have the following. I have 3 squared. Now, if you're familiar with the order of operations, you always start with parentheses and exponents. So again, this is not that complicated. If I do 3 squared, I will have 9, like so. So I've done the 3 squared inside the parentheses, but then I still have the square on the outside. And we know that 9 squared is going to be 81. This is the same as if I had 3 to the 4th power. How did I get to the 4th power? Because, like I already showed you, if you look right here, and if you look right here at our property at the top, when you have an exponent separated by parentheses like this, you just multiply them across. So when you do 2 times 2, you obviously get 4. And so down here, this is how I got 3 to the 4. And just in case you're wondering, to make sure this is extra clear, we can do the following. You know that 3 times 3 equals 9. I've used 1, 2 of my 3s. I should have 4 altogether. So times 3 equals 27. That's our third 3. And then times 3 equals 81. That's our fourth 3. And so you can see right here how these are all equivalent expressions of the same basic ideal here. So just to follow up and make sure this is clear, what I did was as follows. 3 squared becomes 9. 9 squared becomes 81. Another way to look at this is that 3 squared squared is the same as 3 to the 4th power. Going right down here. Because you multiply the exponents together. That's what you do. So it's very clear. But let me give you a few more examples, shall we? So let's take a look at this one. Let's say I have x to the 9, x to the 5. Well, you guys already know what to expect here. You simply multiply these two exponents together and you come up with the following, x to the 45. Not that deep. And then just one more for kicks. You have 3 here again. I just love the number 3 for whatever reason. Squared to the 3rd power. Again, you probably know what to expect. 2 times 3 is going to be 6, so you end up with 3 to the 6th power. Again, not that deep. And so this is how the power property for exponents works out. Let's take a look at a slight variation of this called the product to power property for exponents. And this is where you have the following. So first we'll do the example, then I'll show you the property in terms of an expression. So let's say we have the following. Let's say I have 3 to the y, and then I want to cube this, or to the 3rd power, if you will. Now, to break this down, you just want to make it simple. So what do you have? You have 3 to the y times 3 to the y times 3 to the y. And now you just combine the like terms, and basically you end up with 3 times 3 times 3 times y times y times y, like so. And of course, now you simplify. I mean, I'm sure you're expecting that. And so what do we have? Well, we have 3 times 3 times 3. We can simplify that to 3 to the 3rd power. And we have y times y times y. And we can simplify that to y to the 3rd power. This leads to our principle here. So here we go. Let me do a different color here. I'll use my original color. How about that? Yeah. So this leads to my original point here. A times b, when they're raised to the power of m, is the same as a to the m times b to the m. And that is exactly what we have down here at the bottom, if you can look closely. So in this case, the 3 is the a, the y is the b, if you will, and they were all raised to the same exponent power of 3. Very brilliant and simplistic. Again, the power of this ability to use these properties for these exponents becomes very important when you're trying to solve complex expressions and equations and things of that nature. We need to simplify and find little shortcuts, move things around for a higher purpose. Right now, it's hard to appreciate these things without a particular context, but they do have a value to them. So, in this video, we took a look at power property for exponents. And we started with the power property for exponents, like so, where when you simply have when you have a number, a base number raised to a power, if you will, in parentheses like this, you end up basically with the base number, whatever it is, with the two exponents being multiplied by each other. And so I demonstrated that with the longhand here, with these, and I worked it out like so. And then after that, we did one more example where we looked at the product to a power property. Basically, product, why do we call it a product? Because right here we're multiplying a constant by a variable. That's where the product comes from, but they're all raised to the power of 3 in this particular example. And the basic principle behind this is that when you have two numbers or two constants or a number and a variable, whatever, a number and a variable multiplied together, raised to a particular exponent, it's the same as having the first number raised to that same exponent and having the second number raised to that same exponent, and you multiply them across if you so desire to. And we worked it out here. So I hope this video was clear and useful for you and that it made sense. And so my name is Darren Thomas. I'm the Director of Educational Research Techniques. I want to thank you for watching. Take care.